So in the final section for this chapter, we've got some application problems with consumers surplus and producers surplus. So we're given the functions, and we're going to have to do a little bit of algebra behind the scenes so that we can figure out what our limits of integration are. But we are told in the first one that the demand function for a certain make of replacement cartridges for a water purifier is given by the following equation. P is unit price in dollars. X is the quantity demanded each week measured in units of 1,000. So I'm told that P equals a negative 0.01 x squared minus 0.1 x plus 25. Okay. Now what's given is it says determine the consumer surplus if the market price is set at $5 per cartridge. Well, remember P is price in dollars. So I know that P in this case is going to be 5, and that's going to leave me with the remaining part of the demand function. Okay, so what am I supposed to do with this? Notice that this is quadratic. Okay, so if I can set this equal to 0, I can solve by factoring. So I'm going to subtract 5 from both sides. And now I get 0 equals a negative 0.01 x squared minus 0.1 x plus 20. Now this is ugly and this is nasty. So what we're going to do is we're going to change it just for the purposes of factoring. Okay, and then we'll change it, but we'll come back to our original function later. But for right now, we need to change it for purposes of factoring. So notice that this is 1/100th and it's negative. So if I multiply by a negative 100, it'll make this just a 1x squared. And that'll make my life a whole lot easier. So I'm going to multiply through to all 4 terms, here, 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 by a negative 100. And the entire purpose of that is just to make it easier to factor. So I've got 0 equals positive 1x squared. This is going to be a positive 10x. And this is going to be a negative 2,000. So I need 2 numbers that multiply to a negative 2,000 that add up to a positive 10. So as I go through my head, I find out that those 2 values are going to be x with a positive 50 and x with a negative 40. So positive 50 and negative 40 adds up to 10. Positive 50 times negative 40 gives me negative 2,000. So find your zeros. The 0 of this first one is negative 50. The 0 of the second one is 40. Okay, so now that I know that much, remember what you're dealing with. You're dealing with the demand function. Okay, so it makes no sense to provide a negative quantity of anything. So this we don't need. We don't need a negative quantity. Okay, so once I determine that stuff, what I need to go back at this point is going back through and setting up my entire integral. Sorry, I lost my brain. All right, so I'm going to take this thing from 0 to 40, and I found the 40 through factoring the quadratic, okay? And then I go back to my original function. So my original function is going to be a negative 0.01 x squared minus 0.1 x plus 25 dx, okay? Now, at the end of this whole thing, we're going to have to remember to subtract off the price, the market price, in this case, what was it? It was $5, okay? We're going to have to take that times the equilibrium point. Okay, so we have, when I'm all said and done, I'm going to have to subtract off 40 times 5. Okay, so I'm going to have to subtract off 200. So just remember that when we're all done, okay? So as I go through this, what I have is the following. So I'm going to integrate this. That's going to give me negative 0.01 x to the third over 3 minus 0.1 x squared over 2 and plus 25x. And we're going to take that from 0 to 40. Well, the good news is once we evaluate at 0, the whole thing's going to zero out. So I'm just going to shove in a 40, okay? And I'm going to pause while I put this in the calculator, okay? All right, so when I evaluated it at 40, all of this turned into 706.67, okay? Well, I remember to subtract off your 200. So I actually end up with 506.66666667. Now, why do I have all those? Because remember that we were told that you are measuring in units of 1,000. So I need to take that 506 and I need to multiply it by 1,000. I just multiplied it by 0. And that's going to give me 506,666.67 cents. Okay, so what was our strategy? We ended up finding the price, the market price was set. So set your function equal to the market price. Solve it, set it equal to 0. We just made it easier for factoring by multiplying through by -100. And then we went through, we used this number right here that we found from factoring, and that was our limits of integration. From 0, which would be nothing is produced, up to 40, which is what our equilibrium point. Then I cannot think. I integrated, and then I just remembered at the very end to subtract off 200. So where did the 200 come from? It came from the fact that the price was set at $5 per unit, and our equilibrium point is 200. So 5 times is 40. Goodness. So 5 times 40 is 200. So I need to take off that 200. All right, so we're going to try that again. Maybe my mouth will work this time. All right, so my demand function for a certain brand of CD is given by P equals, and I've got negative 0.01x squared minus 0.1x, and then I have plus 9. So P is the wholesale unit price in dollars, X is the quantity demanded each week, and I'm measuring in units of 1,000. So determine the consumer's surplus in dollars if the market price is set at $7 a disc. Okay, so same process. We're going to set this equal to 7. And then I'm going to subtract 7 from both sides because this is quadratic and I need to factor. So subtract 7, subtract 7. So I've got 0 equals negative 0.01x squared minus 0.1x plus 2. Okay, so now when I'm here, I need to go ahead and just for ease of factoring, I'm going to multiply through by a -100 so that my lead coefficient is just 1. So multiply through by a -100. That's going to give me 0 equals x squared. -100 times -0.1 is going to be positive 10x. And then -100 times 2 is going to be -200. Okay, so when I factor, I need two factors that multiply to -200 that add up to 10. So I am pretty much looking at, let me think, my brain is shot at this point if you can't tell. All right, so this is going to factor down to x plus 20 and x minus 10. So that's the factored form. What are your solutions? This solution is a -20. This solution is a positive 10. I cannot have a negative quantity. So now, I now know my limits of integration. I'm going to go from 0 to 10. So going from 0 to 10 of my original demand function. So I've got a negative 0.01x squared, negative 0.1x plus 9 dx. And remember, what are we going to subtract off? I'm using a 10 times $7 means I need to subtract off 70. Okay, so at the end, I'm going to subtract off 70. So when I integrate, I've got 0.01x to the third over 3 minus 0.1x squared over 2 plus 9x. The good news is when we evaluate at 0, everything's going to zero out. So I just need to throw some 10s in here. And again, I'm going to pause while I do this part on the calculator. All right, so when I did that in my calculator, I got an 0.66666, which is a whole bunch of sixes and a 7. Okay. Well, remember, we got to subtract off 70. So that leaves me with 81 minus 70 is 11. So I have 11.66666 and all of these things. But remember that this is set in thousands of dollars. So multiply that by 1,000 and we're going to get 8166. Oops, sorry. We are not. We're going to get 11,666.67. So $11,666.67. All right, so let's see if we can do another one. So we have the consumer surplus. So our function, the quantity demanded is X hundred units per week. So we're in hundreds. The wholesale unit price is P equals determine the consumer's surplus. If the market price is set at $17 per unit. All right, so my formula is P equals the square root of 361 minus 3x. This one is not quadratic, okay? And this is set to $17 per unit. So I'm going to substitute this for 17. So I've got 361 minus 3x. Well, I'm trying to solve for x. So to get x out from underneath that radical, I need to square both sides. So 17 squared is going to be 289. So I have 289 equals 361 minus 3x. Okay, so I'm going to subtract 361 from both sides. So minus 361 is, and I get 72. And then divide both sides by negative 3. And I get x equals 24. So x equals positive 24. So at this point, we know that our limits of integration are going to go from 0 to 24. And I'm going to go back up to my original function, which was 361 minus 3x to the 1/2 power. Okay, and what are we going to subtract off? We're going to subtract off 24 times 17. So remember to subtract off 24 from 7, or 24 times 17, whatever that is. Let's look. 24 times 17 is 408. So I need to subtract off 408. So I need to balance. What's my u? My u, ooh, look, we can do u substitution. My u is 361 minus 3x. My du is going to be a negative 3 dx. So I am missing the negative 3. So I got a negative 3 here, balance with a negative 1/3. Okay, and I'm going to go ahead and change my limits of integration so I don't have to backtrack. So I've got a negative 1/3. And now if I look at this, if I shove in a 0, I get 361. Okay. If I shove in a 24, 361 minus 3 times 24 is 289. Okay. So notice that those are backwards. Okay. It's going to work itself out because we got a lead negative. So it's okay. So now I've got a u to the 1/2 power du. So when I integrate, I get u to the 1/2 becomes u to the 3/2. Divided by 3/2 is times 2/3, and 2/3 times a negative 1/3 is negative 2/9. U to the 3/2. Okay, so I'm going to take that from 361 to 289. So I'm going to do square root first. Square root of 289 is 17. And then 17 to the 3rd power is going to be 4913. Times a negative 2/9 is going to be, sorry, I forgot my fraction. It's going to be negative 98/26. Negative 98/26 minus, and then this will go negative. So do you see what's going to happen? This was negative, and I'm going to subtract off a larger value that's going to be negative, and so it'll end up flipping. It'll turn positive. All right, so the square root of 361 is going to be 19. Okay, 19 to the third power is going to be 6859. And then 6859 times 2/9 is going to be 13,718 over 9. So now that's a plus positive. So I'm going to take that minus 9826 over 9, math. Actually, I don't want math, fraction. Okay, and I get 3892 over 9. So 3892 divided by 9 gives me 432.44. Okay, but I need to subtract off 408. So minus 408 is, and I get 24.444, but then I need to multiply that by 1,000. So times 1,000 gives me 24,444. Notice all the fours. So $24,444.44. And we'll finish the last two on a different video.